let's look through and make a list of the ones we need to work out. Please ask it. Go ahead and correct these if you have mistakes. I'm just giving you a completion score, and I've already got that now, so this is yours. I won't be collecting it.
Can you just do this on my phone?
Yeah, you can do it on a piece of paper or on your study guide, whatever you like. So number 12, we have the absolute value of 4x plus 1 equals 3x minus 5. So absolute value, we have to pay attention to if it's an equation or an inequality. If it's an equation, we make two separate equations. The first one, nothing changes. The second one, you have to set it equal to a negative. So it's changing the sign of that entire side of the equal sign. Now we solve both of these. So I can subtract my 3x, subtract my 1, so we get x equals negative 6. Over here, this would be negative 3x plus 5. So we add 3x and subtract 1. So we get 7x equals 4, so x is 4 sevenths. Alright, but most of the time, those were your actual answers. This one, it's not. And it all comes back to when you check. If I put in a negative 6, okay, I get negative 24 plus 1, so the absolute value of negative 23 equals negative 18 minus 5. What did I do wrong? Did I copy that down right? Alright. I think I have a mistake on my key, don't I? Is that accurate? Does the absolute value of negative 23 equal 23? No. That says 23 equals negative 23. So that one doesn't work. Alright, let's try the 4 sevenths. So if I plug that in, so that would give me the absolute value of 16 sevenths plus 1, so 23 sevenths equals 12 sevenths minus 5, so 23 sevenths. Does that work? No. So what should the answer really be on this one? No solution. Looks like I crossed off one of my solutions and I just left the other one. No solution on that one. All right. When can that happen on absolute value problems? When do we have those equations where answers don't work? You guys know? Most of the time they worked out. It's because you had an x that wasn't in the absolute value. That's when you really need to be cautious. Sometimes they'll work and sometimes they won't. Sometimes both might work, one might work, or nothing at all. All right, problem 15. So we have negative 3i over 2 plus 5i. We know that in a fraction, you can never have a radical or an I in the denominator. How do we fix that? So 2 minus 5i. Okay, if we distribute, we get negative 6i plus 15i squared. On the bottom you get 4 minus 10i plus 10i. or you may not have even written those down because you knew they canceled. Minus 25I squared. Alright, what do we know about I squared? So this is negative 6I. 15 times negative 1 will make a negative 15. Those cancel, so the bottom is for negative 25 times negative 1 is positive 25. So this is over 29. Now, while that answer is correct, anything with imaginaries has to be written in standard form. And that's what your directions told you. Standard form, A plus BI. So we have to think our real part. So the negative 15 over 29 plus the imaginary. And imaginary is negative 6I over 29. So you can say minus 6 over 29I or 6I over 29. Right, so that was really just a notation thing for how to write the final answer. We didn't ask about 16, but I just want to touch on one thing there. This is a problem that if you just write down the final answer, I'm not giving you any credit because we know there's only 4 possible answers, right? And I have no way of knowing if you just guessed because you had a 25% chance or if you really knew it. So what work would you show me on these? Yeah. So 56 can be broken into I squared to the 28th. I squared is negative 1, and negative 1 to the 28th is 1. What if it had been like 57th power? You would have another I multiplied with it. You would have gotten I for your answer. All right. Now, our favorite, word problems. 17. There were a lot of questions on this one, so let's make sure we're really paying attention here. We have a picture being placed on a mat of uniform width. All right, everyone looked like they started out with the right picture here. We've got this map, and the picture is on it, so it's like the mat is the outside, it's the frame, you've got a picture inside. All right, we know that the mat is 24 inches by 34 inches. When we said uniform width, what is that referring to? How far it is between inside and outside. I didn't tell you what it was, I just told you they were all the same. So we could call those X. This is our picture on the inside, and what I'm giving you is the area of the picture. So let's just think about that picture for a second. Right? If I'm going to find area, we have to have length and width. The entire mat had a length of 34. But if I want to get to the picture, I have to remove this end and remove that end. How big is this end? X. How much is this? So the final picture would be okay, so if I'm looking at this one. From here to here is X. From here to here is X. If I want the picture, I have to chop both of those off. So it would be right, and then I gave you area. How do we find area? Our area of 600. So remember, you have to define your variables. A picture is fine, but make sure there's an X in your picture for that to count as defining your variables so I can look at it and clearly see what X represents. Then we write our equation, so now we solve this. So 34 times 24, what is that? Thank you. Minus 68x. 8x plus 4x squared. Okay, I'm going to write my square term first. So we have 4x squared minus 116x plus 816. What do you do next? Always has to be equal to 0. Alright, so I need things that, I'm checking, do we have a greatest common factor? Can I divide them all by anything? 4. So if I want to, I could just divide both sides by 4. Alright, so what multiplies to a positive 54 adds to negative 29? Set these equal to 0, and we get positive 2, positive 27. Alright, but both of those aren't the answer. I'm looking for the dimensions of the hamburger. X represents the width of the mat showing. What happens if X is 27? Yeah, that would give me a negative, wouldn't it? Give me a negative here, or you could think it's only 24 wide, so it's impossible to have 27 inches showing on each side. So in this problem, the 27 would not make sense. So then to get the picture, you plug your 2 in to these equations. So 34 minus 4 will be 30. 24 minus 4 is 20, and we always answer in a sentence. So the picture is 20 inches by 30 inches. Did that help? Let's look at a couple more problems here. So 18, these mixture problems. We've covered quite a few of these. You can expect you will have a mixture problem on your test. Okay? We are looking at this whenever I have lots of information. I told you you can organize it in a table. What is the formula we use for these mixture problems? Okay, and I've told you you need to write that formula across the top because otherwise I can't tell in your table what X represents. Your labels you have a little more freedom with. You can be really specific, or you could just say first, second, and total. That is 100% up to you. If I just looked at this problem, I have a 7, a 10, and a 15. Can you tell me which percent is my total? 10. How do we know that? You always have to mix the high and the low to get something in between them. So my answer, 10, falls between 7 and 15. Alright, so now we read the question. How many pounds of extra lean hamburger that is 7% fat? So I don't know it. How many would be X? Must be mixed with 30 pounds of hamburger that is 15% fat. So that's 30. Then what's my total? Okay, concentration, 7% would be 15%, and 10%, 0.1 or 0.10. So then you multiply, so you get 0.07x. 30 times 0.15, 4.5. This one you have to distribute. Once you get that column, how do we get our equation? It's always first plus second equals total. So we have 0.07x plus 4.5 equals 0.1x plus 3. If I subtract over my 0.1, subtract over my 4.5, divide by negative 0.03, and we get 50. The question was how many pounds of the 7%, and if I look, that's what X represented. So there must be 50 pounds of 7% fat hamburger. Let me ask you a question here. What if I had told you how many pounds of 7% must be mixed to get 30 pounds in your total? So what if the 30 was the total instead? What would I have done for my 15? So sometimes the number I gave you was for your grand total, and if that's the case, we know these two have to add up to 30, so this one would have to be the total minus X. Okay, it's only you add those two to get your total. Good. All right. Any questions on that one? The other type of word problem, distance problems. We also did a table on these, but we had to think a little more when it came time to write our equations. So we have two different runners, Alan and Katie. What formula goes across the top? Okay. So they are leaving home at the same time. So they're leaving from here and jogging different directions. So one's going this way, one's going that way. All right, Alan travels at a rate that's 2 miles per hour faster than Katie. Do I know how fast Katie's going? So then what would Alan be? Did anyone make Alan X and Katie X minus 2? That would also work. After 2 hours, so what's my 2 hours? Time. So then we can get our distance. And this is where we have to think a little bit. Here are my two distances. Sometimes we have a situation where you go somewhere and you come back. If you go somewhere and come back, what's true about your distances? They're equal. Sometimes we have two people running a race and somebody gets ahead of the first one. I want to know how far apart they are. If you're running the same direction, how do you find out how far apart you are? Subtract. But I'm running different directions. So how do I find my total distance apart? Add them. So I'm going to add those to equal my 28. X equals 24 and X is 6. But you have to answer the question. The question wants Alan's rate. Alan is X plus 2. So how fast is he running? 8 miles per hour. So you will have a couple word problems on your test. Not like 4 or 5, 2. And we've seen the different types. The geometry ones where we have a picture, usually something involving area or perimeter. The mixture problems and the distance problems. All right, let's do some inequalities. Is this helping at all, guys? Or? When we have these inequalities, it starts off just like solving an equation, except you do have to remember if you ever multiply or divide by a negative, what happens to your inequality? It flips. Okay, but I'm not doing that here. I need to start off by factoring. So we don't have a greatest common factor, we can do slip and slide. What multiplies to a negative 60 and adds to positive 11? Don't forget to undo your slip and slide. So 15 over 12 reduces to 5/4. 4 over 12 is 1/3. All right, this is where it's different. In an equation, you set these things both equal to 0. And we'll go ahead and do that. So we get negative 5/4 and positive 1. But then what do we have to make? The number line, our sign line. Make sure you review these before Monday, because I always have people that get to this point and they try to just tell me x is greater than both of them. And you're missing a lot of points by not doing the sign line. You pick test points smaller than negative 5/4, so maybe negative 2. In between the two, so maybe 0, and bigger than 1/3, so a 1. And you are plugging them in to this inequality. I don't care what they equal, I just care if it's positive or negative. So if I put in a negative 2, negative 8 plus 5 is negative, negative 6 minus 1 is negative, 2 negatives make positive. Put in a 0, 0 plus 5 is positive, 0 minus 1 is negative, positive and negative make negative. Put in a 1, 4 plus 5 is positive, 3 minus 1, positive, 2 positives make positive. Do these things have to alternate signs? No. Most of the time they do. So if you get 2 negatives in a row or 2 positives in a row, double check yourself. But it can happen. Now, how do I know which ones I wanted? Greater than. So greater is positive. So we want the 2 positive sections. You have to give me an interval at the end. So this would be negative infinity. How do I know if it's parenthesis or bracket? Right. Doesn't have an equal to, so parenthesis. Union 1/3 to infinity. And we didn't ask about 21. It's the same way. You could divide everything by 2 to start with to have some nicer numbers. Let's talk about 22. Okay. With these rational ones, if it were an equation, if this were just equal to negative 4, what would we do first? Multiply the 2x plus 1 over and get rid of the fraction. But why can't I do that if I have an inequality? Right, I don't know if it's positive or negative, and we know that if it's a negative, it flips the inequality. So since I don't know that, I cannot multiply by my variable. What did we do instead? Add over the 4. That's like a 4 over 1. We know if we want to add or subtract fractions, they have to have a common denominator. So I would have to take this times 2x plus 1 on top and bottom. X for 2x plus 1. Let's say x plus 4 over 2x plus 1. Same denominator, so you add the numerators. 1x plus 8x is 9x plus 4 greater than 0. So I have 2 things divided that have to be positive. That means I could have 2 positive numbers, I could have 2 negative numbers. What do we do? Yeah, we do our sign line. Anytime you have a quadratic or a rational inequality. So for the sign line, you have to set the top and bottom equal to 0. So I get a negative 4/9 and a negative 1/2. All right, negative 1/2 is smaller, so it would go on the left. Test points, so smaller than negative 1/2, maybe a negative 1. In between them, you might have to use your calculator and get a decimal. This is negative 0.5. What's negative 4/9 as a decimal? Okay, so we need something between, so maybe a 0.49. And bigger, we could go with 0. Plugging them into this fraction. So if I put in a negative 1, negative 9 plus 4 is negative. Negative 2 plus 1 is negative. Two negatives make positive. If I put in a negative 0.49, alright, what's the top turn out to be? Positive or negative? Look at all you bums sitting there without even a calculator, just waiting for me to give you an answer. Come on. Plug in the negative 0.49 into the numerator. Do you get a positive or a negative? Okay, what about the denominator? So that would make a negative. Put in a 0. 0 plus 4 is positive. 0 plus 1 is positive, so that section is positive. So, which ones do we want? Positive. It didn't have an equal to, but if it did, not both of these could have a bracket. Which one could not have a bracket, no matter what? The negative 1/2, because it makes the denominator 0. So even if I had made this an equal to, it would only add a bracket on the negative 4/9. The bottom of the fraction is always a parenthesis. Whoops. Is that one okay? Last question. We have the absolute value of x over 2 minus 3/4 less than 2. Alright, absolute value inequality. You have to ask yourself, and or. Remember, less than and great or is an or. So ors, you do the two separate ones, so like on 24. This one is an and, so we just did one big one. So negative 2 less than x over 2 minus 3/4 less than 2. So we add 3/4 to everything. All three pieces. So we get negative 5/4 less than x over 2 less than 11/4. Then what do we have to do? So negative 5/2 less than x less than 11/2. And you should always get a single inequality at the end, or it should be 2. It didn't have an equal to, so it's just parentheses. Negative 5/2 to positive 11/2. Are there any other problems on here that you would like for me to work out? Where do you begin on this? Add over the 1. Okay, that's like 1 over 1. To add or subtract fractions, we need a common denominator. So we're going to multiply by the denominator, x plus 2 on top and bottom. We get 1 minus x over x plus 2 plus x plus 2 over x plus 2. Now when I add these together, what happens to my x's? They cancel. So we just get 3 over x plus 2 less than or equal to 0. Alright, so normally we set top and bottom to 0. Can the top equal 0? No. If you set the bottom we get -2. So since we only have 1 point, we only need 2 test points. Smaller than -2, bigger than -2. Putting them in here, the top is positive no matter what. -3 plus 2 is negative, so that section's negative. Put in a 0, the top is positive, 0 plus 2 is positive, 2 positives make a positive. Which ones did we want? Less than. Less than tells me the negatives. Equal to means bracket. Can I put a bracket on my -2? No. Why? It's from the denominator. So it's just negative infinity to -2. So on these, always get 0 on one side and a single fraction on the other to make your sign line. Anything else? So, we do have a few minutes. If you have any individual questions, please ask. Monday. Test is Monday. There will be no review when you walk in the classroom. Okay, we're just going to start the test. So if you have questions, come see me before then. You guys have advisory Monday. That's kind of nice in the afternoon class. If you need any refreshers or have any questions, come ask in advisory or before school. I will also post the